All right, this is the fourth FRQ on the 2017 BC exam. And this is actually a differential equation problem, even though it doesn't have a slope field, and even though you've got this like dh, you got this derivative. This actually right here is kind of the clue. The way that the equation looks is the clue that it's a differential equation problem, and then also the words differential equation. All right. So first they said to write the equation for the tangent line of the graph at t equals 0, and then use that equation to approximate the internal temperature of the potato at t equals 3. So in the problem, they tell you that at time t equals 0, the temperature is 91 degrees. So they gave us that point 0, 91. So then we need to find the slope at that point. So dh dt evaluated at 0, 91 is negative 1/4, 91 minus 27, because the h is kind of like the y coordinate, right? dh dt is like dy dx, and so we're plugging in the y coordinate or the h coordinate. And then I get negative 1/4, and on my paper I did 91 minus 27 off to the side, and I got 64. So 1/4 of 64 is negative 16, and that's degrees Celsius. Is that what you're doing? No, that's the slope. Just kidding. Whew. Okay, so for our tangent line, we have y minus 91 equals negative 16, x minus 0. Not x and y. H and t. Okay, so h minus 91 equals negative 16t, h equals negative 16t plus 91. So h of 3 is negative 16 times 3 plus 91. 16 times 3 is 48. And so the temperature at 3 is 43 degrees Celsius. So we've got our tangent line, and then we've got our approximation. Part B asks us to use the second derivative to determine whether the answer is an underestimate or overestimate. So whenever I see a second derivative, I automatically think, oh, that's going to give me the concavity of the original function. And so let's go ahead and find that second derivative. So we've got negative 1/4 times h minus 27. I'm going to go ahead and just distribute this. So we've got negative 1/4 h plus 27/4. So if I take the derivative of this, I get negative 1/4. And it's not just negative 1/4, it's times dh dt. The first time I did the problem, I forgot about that part and I got it wrong. So this is actually negative 1/4 times negative 1/4 h minus 27. And so the second derivative is 1/16 h minus 27. Okay, and then to determine the concavity, if I think about time t equals 0, they told us in the problem that the temperature is greater than 27 degrees for t equals 0. So that means that we're going to say h greater than 27 for t is greater than 0. And so that means that this number, subtract 27, is always going to be positive. And so we're going to say that d2h dt squared is greater than 0, which means it's concave up. And so 43 degrees Celsius is, since it's concave up, the tangent line is underneath the curve. And so it's going to be an underestimate. Is an underestimate. So again, the reasoning behind that, I found the second derivative. I looked back at the information in the problem. The information in the problem says if you have a t value, a positive time, anything that's greater than 0, the temperature is bigger than 27. That means that no matter what I plug in, I'm always going to get a positive there. And you can even do this by taking the answer from A and saying, like, I plug in 43, I get a positive answer, obviously. And so 43 is an underestimate because the graph is concave up. So the tangent line is underneath. All right, part C. They give you a different differential equation. They ask you to find an expression for g of t, and they gave you an initial value there, so that means we're going to have a plus c in the problem. We're going to find the c value and all that, and then we're going to go back and evaluate that. So if we go ahead, write out, and this idea of separable differential equations and then finding the exact solution, that is pretty common. It seems, in these FRQs. All right, so I'm going to go ahead and take this chunk and divide it over. That was a DG, by the way. And then I'll integrate each side. So this is a U substitution problem. You could kind of, oh, lunch is ready. You could kind of avoid it if you want because the derivative of g is just 1, but I'm going to go ahead and use that notation anyway. So I have 1 over u to the 2/3, which is really u to the negative 2/3 du. And I'll integrate each side. So if I add 1 to the exponent, I get 1/3. And if I divide by 1/3, then that's kind of like multiplying by 3. And then I can go ahead and plug stuff back in for u. So you can plug in that initial value anytime you want. They said 0.91. Usually I kind of check to see, oh, does it feel like it'd be easy to plug in 0.91? In this case, it feels pretty easy, so I'm going to go ahead and do it. So I've got 3 times 91 minus 27 to the 2/3 equals -0 plus c. I remember that that was 64 from the other part of the problem. Third root of 64 is 4. And then it wasn't 2/3, it was 1/3. Sorry, I took too much from the original. Okay, so that was, the original problem had a 2/3, but when we did the antiderivative, it just had a 1/3. Okay, so we've got the 1/3, I've got the 1/3. Third root of 64 is 4, so c equals 12, and so then I'll go ahead and plug that back in for c. So I can divide the 3 over, and I'll raise everything to the 3rd power. And I'll add the 27. Okay, so there is my equation for g of t. And now I just have to go back and evaluate that for 3. So -1 plus 4 is 3. 3 to the 3rd plus 27. 27 plus 27 is 54. 54 degrees Celsius is what we would assume based on that model.